Hello everyone, welcome to my YouTube channel Tech Spot. This is me, Harish Goupale. So basically in today's video, we are going to discuss about the encoder and the RTL design implementation of 8:3 encoder. Now if I talk about working and functionality of encoder, so basically it is one of the combination circuit as we know everyone, and basically it converts one of the many inputs line into the binary code that represents one of the active input at a time. Okay, and as you can see the block diagram, it has 2 to the power n inputs and n outputs. Means if the value of n is 2, so 2 to the power 2, 4 inputs will be there. As n is the outputs, so 2 outputs will be there. And if the value of n is 3, means 2 to the power 3, so 8 inputs will be there. And as n is the outputs, so 3 outputs will be there. So based on the value of n, we can categorize different types of encoders such as 4:2 encoder and 8:3 encoder. Now if I talk about working and functionality of 8:3 encoder, so basically it has 8 inputs. It can be I0, I1, I2, I3, I4, I5, I6 and I7, and as three outputs are there, so outputs can be Y0, Y1 and Y2. Now I told you, like in encoder, one of the input can be active high at a time, or it detects one of the input active at a time only. So our outputs represents our inputs. Means if my output y0, y1, y2 both are low, that means my input i0 is active. You can see the truth table. You can see if my y0, y1 and y2 both are low, that means my input i0 is active. Okay, if my output y0 is high, y1 is low and y2 is low, so it represents my input i1 is active. Okay, if my output y0 is low, y1 is high, y2 is low, that means that represents input i2 is active. If my output y0 is y0 is high, y1 is high and y2 is low, so that represents my input i3 is active. Okay, if output y0 is low and y1 is low and y2 is high, so that represents input i4 is active. Similarly, for all the inputs, if my y0, y1 and y2 both are high, so that represents my input i7 is active. So this is what the functionality of 8:3 encoder. Now let's jump for the RTL design implementation of 8:3 encoder by using System Verilog on a viewport. So here you can see my screen. I have already written a System Verilog code for the design implementation of 8:3 encoder. So let's go through the code and let's discuss each line of code. Here you can see tick time scale is 1 nanosecond divided by 1 picosecond, and the module name is encoder 8:3, and you can see the outputs from I0 to I7 as we have discussed in the truth table and in the block diagram of 8:3 encoder, and the output is from Y0 to Y2. Okay, and as it is a combination circuit, so in System Verilog we have combinational procedural block that is always formed. So here we have used, and here we have used case statement. We know that case statement says for every possible output we have to provide every possible inputs. Now we can see the logic, and as I have explained in truth table, when my y0, y1 and y2 both are low, that represents my input i0 is active. So here you can see that output y0, y1 and y2 are low, so that represents input i0 is active. When i1 is active, that time output y0 is high, y1 is low and y2 low, that means my input i1 is active. When output y0 is low, y1 is high, y2 is low, that represents input i2 is active. Similarly, when output y0 is high, y1 is high and y2 is low, that represents input i3 is active. Where similarly output y0, y1 are low and y2 is high, that represents input i4 is active. And output y0 and y2 is high and y1 is low, that represents input I5 is active. Similarly, similarly output y0 is low and y2 and y1 are high, that represents input I6 is active. And when all output y0, y1 and y2 are high, that represents input I7 is active. Okay, and by default all the outputs, that is y0, y1 and y2 are low. When I execute this code, then we will get the schematic. Here you can see the schematic. These are the inputs from I0 to I7, and these are nothing but the registers. Okay, 8-bit registers, and outputs y0, y1 and y2. Okay, now to verify this 8:3 encoder, I have written a simple test bench code. Let's discuss the test bench code also. Here you can see that here also the same time scale I have taken from by 1 nanosecond divided by 1 picosecond, and the module name is TB for encoder 8:3. Okay, and here also you can see that inputs I0 to I7 and output Y0 to Y2. So I have taken same inputs and output as I have taken in designing also. Okay, and and you can see the instantiation encoder 8:3 and duty instance dot star. So basically dot star is the wildcard operator. We can use that whenever design inputs and outputs and the input and outputs of this bench are same, then we can use that. It will automatically instantiate all the signals. Okay, now inside the initial begin, I have given value, I have given every possible combinations, inputs for every possible combinations to verify. Okay, now when we do this behavioral simulation, then we will get the waveform. Okay, now let's analyze the waveform. Okay, so here you can see that as while explaining in truth table, I told you when when my y0, y1 and y2 both are low, so that represents my input I0 is active. So here you can see that in waveform y0, y1, y2 both are low, that represents my input I0 is active. Okay, when y0 is high, y1 and y2 are low, that represents I1 is active. Okay, when y0 is low and y1 is high and again y2 is low, that represents input I2 is active. Okay, when y0 and y1 both are high and y2 is low, that represents input I3 is active. Okay, when input I4 is active, when my y0 and y1 are low and y2 is high, that time input I4 is active. Okay, when I5 is active, when my y0 output y0 and y2 are high and y1 is low, that time the input I5 is active. Okay, similarly, 1 minute. When my y0, y1 and y2 both are high, in my truth table also I have explained you, that represent my input I7 is active. So here you can see the in the waveform. And by default, as I have mentioned in the logic, by default outputs are 0. So if I give y0, if none of my inputs are active, that means my outputs are low. Okay, so basically in this video we have discussed about the working and functionality of 8:3 encoder and the RTL design implementation of 8:3 encoder. So if you are watching this video, then please click on the like button, and if you are new to this YouTube channel, then please subscribe to my YouTube channel. Thank you so much.